Threading in Python. Let's take a look at the difference between threads and processes. A process is a program. And the programs we've created up to this point each have a single thread. We can also have a program that has multiple, you'd call this a multi-threaded process, so it's a process with multiple threads, meaning theoretically these can all happen simultaneously. How it works is if you don't have enough processors to handle them simultaneously, and that's how it works in Python, it does time slicing. So we will spend a little bit here. Oh, this needs some more work. This needs some work. It goes back and forth. This guy may have to wait for something. So this guy runs. This guy now has to wait for something else. This guy runs. This guy may have to wait for something else. So they take turns. Without threading, we go one. When this is done, we go here, we go here, we go here. There is no taking turns. So our first tutorial shows how that works. Threads always have to have a function or a method to attach to. This is a threading example that shows how threading doesn't work. So we have a function 1, function 2. This does it 5 times, 5 times, 5 times. We're calling those in sequence. One function has to finish before the other finishes. When we call that, it does 1, 1, 1, 1. They have to go in a sequence. Well, that's fine. That's everything we've programmed up to this point. What happens when we add some threading into this? We need the threading module. So we import the threading module from Python. We still have our 3 functions. This is how we called them before. Now we're creating a thread object, which has to have, yes, it has to have a target. So the thread, this is T1 is created with function 1 as a target, T2, T3. Nothing happens until we start them. We start the thread, and when the thread is done, we don't have to do anything because once the function is done, the thread dies. So let's try that and see what it does. Notice that they don't necessarily go in the right order. In fact, in earlier versions of Python, this used to be a lot more random. They go when they go. Notice how this time around it's like this. So it just depends on which one is busy. Oh, look at there. That one went the same way. So there's not really an ordering. There's everybody rushes and tries to get through the gate at the same time. Except they do have to take turns. What runs these threads? The operating system does. It has a task scheduler. Threading passes this function off to the task scheduler, and it runs it when there is time to run it. Now, what if we want to let the program know that these threads are done? These functions and these threads are complete. Well, if we do start, 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 they start, and the task scheduler runs them when it feels like. These are running on separate threads, but guess what? Our program is also running on a thread. So now we have actually 4 threads. Let's see what happens. Well, it's not exactly what we wanted, is it? We can use something called join. This pauses the main program until the threads join the main program. Or I guess I should say the threads keep going. When they all join the main program thread continues. That might be a better way to explain it. And this launches when all the threads are done. So join is a way to announce to the program, yes, this thread is complete. We can move on. If we want to run a tkinter program and have something else happen at the same time as the GUI, we might think that we could do it this way. So this is called threading app, but it really doesn't do anything but set up a GUI. And here's my update time function. You'd think this would work just fine because we've done this before. It should go through and display the time. When my button clicks it should display the time. Let's see what happens. There we are. Start time. Well, it freezes. Why is that? Well, because with tkinter and all of our programs we've done before, we can only run one thread at a time. The main thread runs the GUI display. The minute we start running this loop, we shut down the program. Oops, that's not supposed to be in there. We shut down the program. Well, if we want to do more than one thing at a time, if we want a tkinter program or any other program to have more than one thread, do more than one thing at a time, we need a thread. Notice I can move this around, start the thread, it does its time. I can move it around. I can stop the thread. I can still move it around. I can start the thread again. I can still move it around. I can stop the thread. So I have complete control of this background task as well as complete control of the foreground task of running tkinter. So this is running with two threads. If we want to do anything independent in a graphical user interface, we need more than one thread. Let's see how this works. All right, so we're importing thread and event. We've done thread before. Here's tkinter stuff, nothing new here. We need this event in order to stop the thread. The thread keeps track of what sort of event has the thread sent us. Is it running or not? Might be a way to look at it. And all we're doing here is setting up the GUI. That's all in the thing. Here's our start thread and our stop thread. Here's our background task. Now this loop's a little different. While the self-stop event is not set, it's going to keep going. So if it is set, that means that we want it to stop. Right? So while it's not set, we keep looping. While it is set, we jump out and we don't do anything. We stop the task. I know that's kind of counterintuitive. I tried to figure out a better way to program it, but that's what I have for now. And here's how we start the thread. We start it, we clear the event, then we start the thread. It runs as a background task, and here's a safety measure when you're using threads, is to make it a daemon thread. That way, no matter what happens, the thread closes when the program ends. And here we are setting the stop event to signal the thread to stop. So while this is not set, we keep running. When we set the stop event, that means that we stop the thread. When we close the program, we stop the thread from running and destroy the window. That's it. We'll see you later. We'll do some more threading later on.